Hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. So today we are going to enter a new chapter and the very last chapter for our semester one, chapter 7, ionic equilibria, and we are going into subtopic 7.1, part 1, acid and bases. So there are a few learning outcomes that we are going to cover for today. First one, we are going to define acid and base according to Arrhenius and Bronsted-Lowry theories. Second one, we are going to identify conjugate acid and conjugate base according to Bronsted-Lowry theory. Third one, we are going to relate the pH and pOH to the ionic product of water, Kw, at 25 degrees Celsius. Next, we are going to define strong acid and base, weak acid and base, pH, pOH, and pKw. Next, we are going to calculate the pH values of a strong acid and base. Next, we are going to relate the strength of a weak acid and weak base to the respective dissociation constant Ka and Kb. And lastly, we are going to perform calculations involving pH, dissociation constant, initial concentration and equilibrium concentration, and degree of dissociation alpha. Okay, and remarks the performing the calculation only on weak monoprotic acid and monoprotic base. Okay, so we're going to start our tutorial now. Hey, so let's go into the first part, which is definition of acids and base. So basically, we have three three theories that define the acid and base. However, in our recent syllabus, the theories that we are going to cover are just two, but I'm going to teach you three theories just in case. Okay, the main theories that you are going to learn are two, which are Arrhenius theory and Bronsted-Lowry theory. And the additional theory that I am going to teach you, although it is not in the learning outcome in the syllabus, but I'm going to teach you just in case ada tahu keluar kan. So it's a Lewis theory. So let's define acid and bases based on these three theories. Okay, so the first one is Arrhenius theory. So it says that here that the definition of acid based on the Arrhenius theory is the acid is the substance that ionized in aqueous solution to produce hydrogen or hydronium ions. Okay, for example, it has hydrochloric acid here forming hydrogen ion and chlorine ion, or hydrochloric acid react with water to form hydronium ion and chlorine ion. So this is the definition of acids based on Arrhenius theory. So what is the definition of bases based on Arrhenius theory? So bases in Arrhenius theory is the substances that ionize in aqueous solution to produce hydroxide ions, OH minus ion. So for example, we have sodium hydroxide aqueous to form sodium ion aqueous and hydroxide ions aqueous. Okay, so these are the definition of acid and bases based on the Arrhenius theory. So let's go to the definition of acids and bases based on the Bronsted-Lowry theory. So the Bronsted-Lowry theory is a combination or like a joint venture of two like scientists, which is Bronsted and Lowry. They come up with this theory to define the acid and base. Okay, so what does the Bronsted-Lowry theory define acid as? So it defines acid as the proton donors, which is the substance that can donate proton to another substance. Okay, so for example, here we have hydrochloric acid as an acid and water as a base. So it will form hydronium ion and chlorine ion. Here, if we see here, hydrochloric acid will form into chlorine ion. So here we can say that HCl donating proton to another substance, hence becoming Cl minus at the end of the reaction. Okay, so where does the H plus go? So the H plus go to the base here. So base is the proton acceptor here, where at the end of the reaction, it will accept proton from HCl just now to form hydronium ion. So we can say that HCl is the acid in the Bronsted-Lowry theory because it donates proton to another substances. So HCl is a proton donor. So HCl is an acid according to Bronsted-Lowry theory. So what is the definition of base based on the Bronsted-Lowry theory? So tadi, the opposite. Kalau acid the proton donor, so base is the proton acceptor. So base is a proton acceptor based on Bronsted-Lowry theory, which means that any substances that can accept proton from another substance is a base according to Bronsted-Lowry theory. For example, here we have NH3 as base react with water is acid. So here water can act as base and acid. So remember that according to Bronsted-Lowry theory, water can behave as acid and acid and base. I'm sorry. So here, NH3 is a base and water is an acid. So remember that base is the proton acceptor. So now, at the end of the reaction, NH3 will become NH4 plus. It gain 1H plus ion here from water. So it accept proton. So we can say that NH3 accept proton to form NH4 plus. So that is why NH3 is a base according to Bronsted-Lowry theory. Okay, so there is one more theory that define acid and base, which is it is not covered in the learning outcome, in the recent learning outcome, but I'm going to teach you anyway. So here is the additional notes on definition of acid and base. So I just thought that why not I share it with you guys, this theory. So here it goes. I don't have space on the page 1, so I put it in the page, I don't know page, how many page is this? Page 3, I think. So this is the definition of acid and bases based on Lewis theory. So Lewis come up with this theory to define the acid and bases. So what Lewis state for acid? So Lewis defined acid as the electron pair acceptor, which means any substances that can accept a pair of electron in the formation of dative bond is a Lewis acid. So for example here, we have water. So water here is the Lewis acid. Why? Because it can accept So H plus here is the Lewis acid. Okay, Lewis acid because it can accept one pair of electron from water to form in the formation of dative bond. So H plus here is the Lewis acid according to Lewis theory. So here, this is the, so NH3 here is the Lewis base. Why? Because Lewis base is the electron pair donors, which means any substances that can donate a pair of electron in the formation of dative bond. So here, NH3 is a Lewis base because it donates a pair of electrons. So maksudnya BH3 here is a Lewis acid because BH3 can accept a pair of electron from NH3. So remember, Lewis acid is an electron pair acceptor, which means that it can accept a pair of electron in the formation of dative bond. And Lewis base is the electron pair donors, which means that it can donate a pair of electron in the formation of dative bond. So that is the definition of acid and bases based on the Lewis theory. Okay, so let's get back. So let's get back to the first page just now. So we have finished defined all the acid and bases based on the three theories. First one is Arrhenius theory, second one is Bronsted-Lowry theory, and the last one is the Lewis theory. So now we are going to look at the second part of this chapter, which is conjugate acid and bases. So what is conjugate acid and conjugate bases? So conjugate acid is a species that is formed when a Bronsted-Lowry base accepts a proton. Okay, so a species formed when a Bronsted-Lowry base accepts a proton. And what is conjugate base? So conjugate base is a species formed when a Bronsted-Lowry acid donates a proton. Okay, so just from the definition, you cannot imagine. So what is actually conjugate acid and base? So I'm going to show you an example. So let's look at this example below. If you look at this one, you can see that H2PO4 minus aqueous is an acid react with NH3 aqueous, which is base, to form HPO42 minus aqueous, which is conjugate based, and NH4 plus, which is a conjugate acid. So I just said just now, conjugate acid is a species formed when a Bronsted-Lowry base accepts a proton. So NH3 is a base according to Bronsted-Lowry base. So it accepts a proton to form a conjugate acid. So NH4 plus is a conjugate acid because it is a species formed when a NH3 accepts a proton. So dia macam berlawanan daripada base lah. Okay, so now when NH3 base accept a proton, it will form a conjugate acid NH4 plus. So same goes to H2PO4 minus acid. So when it donates a proton, it will form a conjugate base, which is HPO4 2 minus. Okay, alright. So that is all for conjugate acid and base. So now we are going to look at the part C, which is strength of acids and base. So there are 4 strengths that we are going to look. First one, we are going to look at strong acid, second strong bases, third weak acid, and fourth weak bases. So let's look at the strong acid first. So what is the definition of strong acid? So strong acid is a substances that is completely ionized in aqueous solution to produce high concentration of H plus and hydronium ion. So substances that completely ionized, 100% ionized in aqueous solution to produce a very high concentration of hydroxide or of hydrogen, and hydronium ion is a strong acid. For example, here we have HCl, we have HBr, HI, HNO3, H2SO4, HClO3, and HClO4. So all these are some of the example of strong acid. So if we do the chemical equation for the dissociation of strong acid, we have to go for a full-headed arrow because this indicates the 100% ionization of strong acid. So HCl is completely ionized in aqueous solution to produce a high concentration of hydronium ion and chlorine ion. Okay, so that is for strong base, a strong acid. So what is strong bases? So strong bases is the substance that is completely ionized in aqueous solution to produce high concentration of OH minus ion. Okay, so here we use same full-headed arrow to indicate that the base is has been 100% ionized, completely ionized to form the OH minus ion. So example of strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, and beryllium hydroxide. Okay, any hydroxide from group 1 and 2 elements are strong base. Okay, alright. So now we are going to look at weak acid. So what is weak acid? So weak acid is a substances that is partially ionized in aqueous solution to produce low concentration of hydrogen or hydronium ion. Okay, here we use this half-headed arrow, which is uh, reversible half-headed arrow, to indicate that this acid can only partially ionize to form hydrogen or hydronium ion. Okay, so here for example we have HF acid react with water to form fluorine ion and hydronium ion. So example of weak acid are HF, HCN, HNO2, HCOOH, and H2CO3. Okay, these are the example, some of the example of weak acid. Next, we are going to look at what is weak base. So weak base is a substances that is partially ionized in aqueous solution to produce low concentration of hydroxide ion. So here we are using this partially headed, half-headed reversible arrow to indicate that the weak acid and bases can only partially ionize in aqueous solution. So we have NH3 aqueous react in water to form NH plus ion and hydroxide ion. So the example of weak bases are NH3, CH3, NH2, CH, C5H5, and so these are some of the weak bases. So we have learned on the four acid and bases, which are strong acid, strong bases, weak acid, and weak bases, along with its example. Okay, so now we are going to look at the definition of pH and pOH. Okay, so what is pH and what is pOH? So pH here is the negative logarithm of the concentration of hydrogen or hydronium ion. For example, we know that pH is equals to negative log concentration of H plus, or pH is equals to negative log concentration of H3O positive plus. So which means that if question give you the concentration of hydrogen ion or hydronium ion, we can use to find pH, or if we have pH, we can find the concentration of hydrogen ion or hydronium ion. Okay, so what is pOH? So pOH is the negative logarithm of the concentration of hydroxide ion. So we have pOH equals to negative log concentration of OH minus. So which means that if the question gives you the concentration of hydroxide ion, we can use to find the pOH. And otherwise, if the question gives you the pOH, we can use it to find the concentration of hydroxide ion. Okay, so notes here that if the pH is less than 7, then the solution is acidic. If the pH is equals to 7, then the solution is neutral. And if the solution has the pH of more than 7, then we can see that the solution is basic. Okay, so let's look at the example here. So here we have the example. Calculate the pH of solution if the concentration of hydrogen ion is 5 times 10 to the power of negative 4 molar. State whether the solution is acidic, neutral, or basic. So first of all, it gives you the concentration of hydrogen ion, which means that we can find the pH, because pH is equals to negative log concentration of hydrogen ion. So we substitute all the information that we have, then we tekan calculator, we put inside the calculator, and we got pH is equals to 3.3. So here, since the pH is less than 7, then we can conclude that the solution is acidic. Okay? Alright. So this is the notes from before. Okay, so now we're going to look at the ionization of water at 25 degrees Celsius. or the ionic product of water, Kw. Okay, so we know that water is it can act as acid and base here, right? So it can undergo auto ionization, which is from water it can form hydrogen ion H plus and hydroxide ion aqueous. So we can say that in the equilibrium constant Kc is equals to concentration of H plus times the concentration of OH minus divided by the concentration of water. However, since the degree of dissociation of water molecule is extremely small, so we can assume that the concentration of water will remain unchanged. So here we can say that we can bawakan pergi sini. So the KCH2O is equals to concentration of hydrogen ion times concentration of hydroxide ion. So this is actually the Kw. So we can conclude that the Kw, the ionic product of water, Kw is the concentration of H plus times the concentration of OH minus. Okay, so at 25 degrees Celsius, the concentration of hydrogen ion and hydroxide ion is equals to 1 times 10 to the power of negative 7 molar. So we know that the Kw here is the multiplication of H plus and OH minus. So when we times it, we can get the product of Kw is 1.0 times 10 to the power of negative 14 molar squared, or mole squared per liter squared. Okay, dia ada banyak lah kan. Kalau you expand the M, you can get the mole squared per liter squared. Okay, so that is for Kw. So Kw is actually the ionic product of water. Okay, which is Kw is equals to concentration of hydrogen ion times concentration of hydroxide ion. Okay, so remember the value of Kw here, okay, is equal to 1 times 10 to the power of negative 14. Next, we are going to look at the relationship between the pH and pOH with the ionic product of water just now. So, first, we take the negative logarithm of both sides of equation. So, kita letak negative log dekat dua-dua. So, if we look, put here, we put the negative log Kw equals to negative log H plus negative log OH minus. So, we get pKw is equals to pH plus pOH. Okay, so here we have at 25 degrees Celsius, we know that Kw is equals to 1 times 10 to the power of negative 14 molar squared. So we have negative log here. So kita substitutekan dia punya nilai ni dalam dia yang formula yang ada negative log ni. Okay, so we know that negative log is equals negative log times 1 times 10 to the power of negative 14 is equals to this, pH plus pOH. Betul tak? So we get 14. So hasil dia punya ni dapat 14 is equals to pH plus pOH. So dekat sini, if we get pH, so if the question gives you pH, we can use this formula to find pOH. And if the question gives you pOH, you can use this equation as well to find the pH. Okay? Alright. For example here, we have example here. It says that the concentration of hydroxide ion in a solution is 2.5 times 10 to the power of negative 5 molar. Dia bagi kita concentration of hydroxide ion. So the question asks you to calculate the concentration of hydrogen ion in the solution. Okay, dia bagi kita hydroxide ion, kita kena cari hydrogen ion. So kita boleh cari guna Kw tadi ni. So Kw kita tahu dia punya nilai dia berapa, betul? So kita tahu nilai and we know the value of hydroxide ion. So can we find the hydrogen ion? Yes, we can find the concentration of hydrogen ion now. So we got that the hydrogen ion here, according to the calculation, we got 4 times 10 to the power of negative 10 molar. So the second question asks you to determine the pH of the solution. So now we can use pH is equals to negative log concentration of H plus. So, kita substitute value yang kita dapat from A into the B. We get the pH value of the solution is 9.4. So kalau soalan tanya, so is this solution acidic, base or neutral? So since the pH is more than 7, so the solution is basic. Okay? Right. Now, we are going to look at the next part of this chapter, which is calculating the pH values of strong acids and strong base. So just now we have learned about the definition of strong acid and strong base. So strong acid is a substance that can completely ionize to form H plus or H3O plus ion. And strong base is a substance that can completely ionize to form OH minus ion. So which means they're completely ionized. Okay, so if we look at this question here, we have strong acid here. So HCl plus water forming Cl minus and hydronium ion. So we have, so here we can, here we have the molarity of hydrochloric acid is 0.1 mole, 0.1 molar. So we know that 1 mole of hydrochloric acid will form 1 mole of hydronium ion. So since the strong acid can completely dissociate or completely ionize to form the hydronium ion, so we assume that it also can form 0.1 molar of hydronium ion. So they completely dissociate. Kan? Sebab awak tahu 1 mole of HCl forming 1 mole of H2O plus ion. And since HCl ni boleh completely dissociate, so dia pun boleh form sama juga 0.1 molar H3O plus. So kita boleh cari pH here. pH is equal to negative log H3O plus. So we get the pH is 1. Okay. So next we are going to look on how to calculate the strong base. So we have calcium hydroxide here to form calcium ion and OH minus ion. So here we can see from the equation here that 1 mole of calcium hydroxide can form 2 mole of hydroxide ion. So 1 mole dengan 2 mole. Since they can completely dissociate. Betul tak? Sebab strong base pun boleh completely dissociate ataupun completely ionize. So which means 0.1 molar sebab dia ada 2 mole kat sini times 2, which means dia ada 0.2 molar here. So we can find the pOH here. Okay, kita find pOH dulu sebab kita ada OH kan? Sebab pOH is negative log OH minus ion. So kita masukkan concentration of OH minus here. So we get the pOH is 0.7. So we know that pH plus pOH is equals to 14. So we know the value of pOH. So can we find the pH? Yes. So the pH is equals to 14 minus pOH. So we got pH is equals to 13.3. So since the pH is more than 7, so it is a very strong base. Okay, dan dekat dengan 14, so maksudnya sangat-sangat strong. Okay, alright. So we have learned on how to calculate the pH for strong acid and strong base. So now we are going to look at the weak acid and weak base. So the first thing that we are going to learn is about the dissociation constant of weak acid and weak bases. So first, what is the use of dissociation constant? It is used to distinguish the relative acidity strength of weak acid and weak base. Okay, so there are two different of dissociation constant. The first one is acid dissociation constant, which is Ka, and the second one is base dissociation constant, which is Kb. Okay, so cara nak buat dia punya expression sama macam yang chapter 6 hari tu. We just use here product over reactant. So kat sini kita tahu this is the product, right? So this is the reactant. But liquid kita tak involve kan sebab dia punya concentration remain unchanged. So here the acid dissociation constant Ka is equals to concentration of A minus. Okay, kat sini concentration of A minus Okay, react times dengan concentration of H3O plus divide by concentration of HA. So this is the expression for Ka. So for Kb sama juga. Okay, we don't include water sebab we remain unchanged. So BH plus ion times OH minus ion divide by concentration of B to find the Kb value. Okay, so for example here, we have the question here. It says that methylamine CH3 and H2 is a weak base that partially dissociated in aqueous solution. So if the pH of 0.02 molar methylamine acid is 11.5, determine the dissociation constant of methylamine. So dissociation constant ni in terms of base kan. So nak apa ni? K, B, betul? First step, apa kita kena buat? Dia bagi kita pH, betul tak? Dia bagi kita pH, maksudnya kita boleh cari concentration of hydrogen ion. So, no. Dia bagi kita pH, dia banyak cara sebenarnya. Boleh juga you nak cari macam nak cari concentration of H+, lepas tu guna yang tapi macam leceh kan. So, satu lagi cara yang simple yang saya lupa, you boleh guna pH plus POH sama dengan 40. So, sebabkan bagi you pH, you boleh cari POH kan. Bila dah cari POH, boleh tak cari dia punya concentration of OH minus? Yes, we can find the concentration of OH minus. So, kita dapat concentration of OH minus here is 3.16 times 10 to the power of negative 3 molar. Okay, so kita kena guna cara untuk weak acid and base, we have to use this ice table from the chapter 6 yang kita dah belajar dulu. Okay, so ice table here, we do the ice table macam biasa. So we do the chemical equation, balanced chemical equation. So we got this, CH3 and H2 react with water to form CH3 and H3 plus OH minus aqueous. So remember, initially, this methylamine has 0.02 molar. Water langsung kita ignore. And then, sebabkan initial product tak ada lagi kan. So, 0, 0. So, change dia mestilah sebab dia tak ada stoichiometric coefficient kat depan ni. So, kita minus X only. Same goes to product. Sebab product is formed, right? So, dia plus X and plus X here. So, at equilibrium, we got this. 0.02 minus X and for product, X dengan X. Okay. So, we know that X here actually is the concentration of OH minus. Betul tak? So, kita dah dapat actually concentration of OH minus here. 3.16 times 10 negative 3, betul tak? So, we know that actually X is equals to 3.16 times 10 negative 3. Okay. So, we need to find the dissociation constant, Kb. Okay. So, we know that Kb is equals to CH3 and H3 plus times concentration of OH minus divide by methylamine punya concentration in equilibrium. Okay, sebab nama pun dissociation constant mesti dalam equilibrium. So, kita kena ambil yang dekat sini. Okay, so X squared lah kiranya kan. So, X squared divide by 0.02 minus X, betul? So, kita akan dapat, kita substitutekan terus nilai X dalam ni. So, kita akan dapat the value of Kb is 5.93 times 10 negative 4. So, dissociation constant does not have any unit. Okay. So, this is how you find the dissociation constant for Kb. Kalau soalan tanya untuk acid pun sama juga. Kena buat ice table, kena cari value X untuk dapatkan Ka. Okay. But depends on question. Kalau dia bagi POH, kena guna cara ni lah. Kalau untuk acid lah. Kan? Senang cerita, kalau dia bagi, contohlah untuk acid, right? For acid, dia bagi you pH. So, directly you can find concentration of H+. Tapi kalau dia bagi untuk acid, tapi dia bagi POH, then you have to use this equation lah. pH plus POH untuk dapatkan pH kan? Sebab dia bagi you POH kan? So, sama je. Any question, pusing-pusing pun, that's how you solve the problems, okay? Yang penting you have to understand the concept of the pH, POH, Ka, Kb, pKa, pKb, pKw, Kw, semua tu nanti kita akan belajar. Okay, faham konsep? InsyaAllah, senang. Okay, so now kita nak tengok baru cakap. So now we are going to look at the relationship between Ka, Kb, Kw, and then kita nak tengok pKa, pKb and pKw. Okay, macam PKPB, PKPD semua kan. Tapi bukan, okay. So ini adalah untuk chemistry punya. Okay, so what is pKa? So pKa is basically the negative logarithm for Ka. So pKa is the negative log Ka. pKb as well is the negative logarithm for Kb. So pKb is the negative log Kb. So Ka times Kb is actually equals to Kw. Okay, so we know that at 25 degrees Celsius, Kw is actually 1 times 10 to the power of negative 14. Okay, so sekarang ni kita tahu sebabkan pKa plus pKb sama dengan pKw. So we know that pKa plus pKb akan equals to 40. Okay, let's look at the relationship between the Ka, Kb, pH semua tu. Okay, here we have this scale here. Sampai kosong is a very strong acid. 7 is a neutral. 14 is a very strong base. So this is a base, this is acid. So, kita tengok 4 acid dulu. Okay, so the higher the concentration of H plus or H3O plus, so the larger the value of Ka. Okay, bila the value of Ka makin larger, the value of pKa makin smaller. So, pH pun makin smaller. Okay, so dia akan jadi more acidic. Okay, so bila dia more acidic, maksudnya dia strong acid. Okay, untuk base pula. The higher the concentration of OH minus, the larger the value of Kb. So, when the value of Kb is larger, the value of pKb becomes smaller. So, when the value of pKb becomes smaller, it will have a bigger pH. So, bila dia ada bigger pH, dia akan jadi more basic. So, bila dia more basic, we know that dia ada strong base. Okay, so these are the relationship between concentration of ion, lepas tu between the value of Ka, Kb, between the value of pKa, pKb, and the value of pH. Okay? Yes. Alright. So, make sure you understand this concept, okay? So, next we are going to look at degree of dissociation or degree of ionization. Mana-mana lah. Sebab apa? It gives the same meaning. Dissociation and ionization is the same. Okay, or alpha. So, what is degree of dissociation? We have learned this as well masa dekat chapter 6. Sama je. It's the ratio of concentration. Tapi cuma beza sikit lah. Kat sini kita ada spesifik lah untuk acid and base. So, the ratio of concentration of H3O plus or H plus ion or OH minus ion dissociated to the initial concentration of acid and base. Okay, so dia ada values from 0 to 1. Tapi kalau in terms of percentage, daripada 0 to 100% lah. Okay, so dekat sini kita ada degree of dissociation is equals to concentration of hydronium ion ataupun H plus ion ataupun OH minus ions dissociated, kita panggil dia X. Divide by initial concentration of acid ataupun base, kita panggil dia C. So, maksudnya alpha is actually equals to X over C. Okay? So, kalau kita nak tukar jadi percentage, so percentage of dissociation is equals to X over C times 100%. Okay? So, that is for degree of dissociation. So, it's very simple. Okay. So, now we are going to move on the last part. Okay, this is the most important part because question often asks you this kind of question. So, calculation related to weak acid and weak bases. So, since the weak acid and weak bases are partially dissociated in aqueous solution, so an approximation method is applied. So, terms and condition applied lah, okay? So, kita tengok kat sini. Example. So, calculate the pH and degree of dissociation of 0.01 molar benzoic acid. Okay. So, dia bagi kita Ka dia C6H5COOH. Sama dengan 6.5 times 10 negative 5. So, sama juga. Kita kena buat dia punya I stable. So, bila buat I stable, kita dapat kita punya Ka expression kita macam ni. So, kita tahu 6.5 times 10 to the power negative 5 is equals to x squared divided by 0.01 minus x. So, sebabkan weak acid kan KA dia very, very small. So, kita boleh guna approximation method. Tapi ada syarat dia. Okay. So, syarat dia adalah kita kena make sure that if we got the percentage of dissociation less than 5%, we can use the approximation method. So, let's look at this one. So, kita assume dulu. Kita assume dulu that 0.01, this one, minus dengan x, dia tak akan beza. So, approximately becomes 0.01 juga. So, kita akan dapat x kat sini equals to 8.06 times 10 negative 4. Okay. So, kita boleh cari percentage of dissociation here. Okay. So, kita dapat kat sini 8.06%, which is larger than 5%. So, we cannot use the approximation method. So, we need to use the quadratic formula to find the x. Okay, so we use the quadratic formula. We got two different values, but we ignore the negative value. Sebab mana ada concentration negative value, right? So, we got x is equals to 4.08 times 10 negative 3, which is equals to the concentration of H3O plus ion. So, we can find the pH by substitute the concentration of H3O plus ion inside the equation, so the formula. So, we get the pH is equals to 2.39. Okay? Alright. So, yeah. So, this is the explanation video for part 1. So, after this, I'm going to make second video to discuss the tutorial question. Okay, I don't want to make the video too long. So, yeah. Alright. So, you need to look at the... So, before that. Okay, since we have what we call it, since we have learned about chapter 7.1 part 1, and I have explained to you all the things that you need to know in part 1. So, please answer the quiz, okay, because this will indicate your attendance, because I will look at your answer. Kalau you jawab, maksudnya you hadir and you betul-betul tengok this video lah. Okay. So, I have explained to you all the things that you need to know. So, this is the first video for part 1. So, the second video for part 1 is actually just for the explanation for how to answer the tutorial question. So, yeah. So, this is for part 1. So, yeah. So, scan this QR code, okay? Alright. So, yeah. Okay? So, that is all for the video. So, that is all for the first video for the part 1. So, after this, kita tengok part 2 pula, okay? Bye-bye.